Hello students, in this section let us see what is axillary circle of an ellipse. From that, how to define eccentric angle of point. From that, how to define the parametric equations of ellipse, and let us see some more applications to the parametric equations of the ellipse, the concept related to ellipse. The first one is axillary circle. What is axillary circle of ellipse? See the definition. This is a circle described as the major axis of an ellipse as diameter, called the axillary circle of the ellipse. Axillary circle is the circle which is described as the major axis of an ellipse as diameter. So, major axis of an ellipse is taken as diameter. We construct a circle. That circle is called axillary circle of the ellipse. So, is it concentric circle to the ellipse or not? Center of the ellipse is 0, 0. Then the center of the axillary circle is also 0, 0. So, the axillary circle is a circle described on major axis of an ellipse as diameter. Let us see. The equation of axillary circle of x square by a square plus y square by b square equal to 1 is x square plus y square equal to a square. Because what is the length of the major axis? 2a. It is diameter, then its radius becomes what? A. What is the center? 0, 0. So the equation of circle with center at 0, 0 and radius a is x square plus y square is equals to a square. How to draw this one? Let us see. This is x-axis, y-axis. This is my ellipse. X square by a square plus y square by b square is equals to 1. This is my major axis. Now we have to construct the circle described on this major axis as diameter. Okay. These are foci of the ellipse S and S dash. Okay. This is the center of the circle. Now we are going to draw the axillary circle. What are these two? A dash and A. These are vertices. Now this is the circle, axillary circle, described on A dash as diameter. I repeat once again. This is the axillary circle. The circle described on major axis as diameter is called axillary circle. This is a concentric with the center of the ellipse and having radius is a units. This is a. Automatically this is also a. Here to here is a. What is the distance from here to here? B. So A is always greater than B. This is my axillary circle. The circle described on major axis as diameter of the ellipse is called axillary circle. Now let us see the next definition. The eccentric angle of point on the ellipse is what? How to find the eccentric angle of any point on the ellipse? How to define that one? Let us see. P is any point on the ellipse x square by a square plus y square by b square is equals to 1. Now draw perpendicular Pn from P to the axis. So take any ellipse, that is x square by a square plus y square by b square equal to 1. P is any point on the ellipse. We are going to find the eccentric angle of the point P which is on the ellipse. For that, what is your first step? Draw Pn, that is perpendicular from P to the axis of the ellipse. What is the axis of ellipse here? X-axis for a greater than b. Now produce NP up to Q where it meets the axillary circle. What is NP? Produce NP up to Q where it meets the axillary circle. Join CQ. What is C? Center of the circle. Now, how to draw this figure? Let us see. This is x-axis. This is my ellipse. X square by a square plus y square by b square is equals to 1. This is the center of the ellipse C. This is the corresponding axillary circle. What is axillary circle? The circle described on major axis as diameter is called axillary circle. This is my point P. We are going to find the eccentric angle of point P with respect to this ellipse. So what we have to do? First of all, draw PN perpendicular from P to axis. How to draw this one? See here. This is the perpendicular PN from P to axis. This is my N. That is nothing but N is foot of perpendicular drawn from P to the axis of the ellipse. Now produce NP up to Q. This is my point Q, where it meets the axillary circle. This is PN. Now we produce NP up to Q, where it meets the axillary circle. Okay. Again join C to Q. Now join C to Q as shown in the figure. This is CQ. So we have an angle theta. Suppose this is theta. What is that? Angle QCN. If angle QCN is theta, then that theta is called eccentric angle of this point P with respect to the ellipse. With respect to the ellipse. So if it is theta, what is theta? Angle QCN is theta. Then theta is called the eccentric angle of the point P with respect to the ellipse. So if you want to find out the eccentric angle of any point P on the ellipse, draw the perpendicular from P to the axis and produce that perpendicular up to Q where it meets the axillary circle. You just join that point to the center, take the angle QCN, that theta is called eccentric angle of the point P with respect to the ellipse. So that theta is called eccentric angle of point P with respect to the ellipse. This theta is lies between 0 to 2 pi. Understand? This is the way to define the eccentric angle of point P with respect to the ellipse. With the help of this eccentric angle, we can derive the parametric equations of the ellipse. Okay. Now, angle QCN is theta. That theta is called the eccentric angle of the point P with respect to the ellipse. Okay. Now, how to derive the parametric equations of ellipse? Same story. This is my point P on the ellipse. We are going to find out the parametric equations of this ellipse. P is any point on the ellipse. Draw Pn perpendicular from P to the axis. Produce NP up to Q where it meets the axillary circle. Join CQ. Then angle theta, that is QCN is theta. Then the eccentric angle of point P is what? Theta. Let P be the eccentric angle of the point P of the ellipse. Then the parametric equations are taken as x square by a square plus y square by b square equal to 1, or x is equals to a cos theta, y is equals to b sin theta. X equal to what? A cos theta, y is equals to b sin theta, where theta is parameter lies between 0 to 2 pi. Okay. Let P be any point on the ellipse as shown in this figure. Already we explained. Q is the corresponding point on the axillary circle. What is that? Q is its corresponding point on the axillary circle. Now my question is, what is the distance from here to here? CQ is A, because this is axillary circle. Radius of axillary circle is what? A, because half of the major axis. Major axis length is 2A, 2A by 2, A. This is A and this is theta. So some line having length A units and that makes an angle theta with positive direction of x-axis. Can I take the coordinates of Q or not? By the parametric equations of straight line, we take the point as Q as A cos theta comma B sin theta. So here the angle QCN is theta. Now the coordinates of Q are taken as a cos theta comma a sin theta. This is my point Q. With the help of Q, can I find the coordinates of P or not? This is ordinate. This is ordinate. On ordinate, which one is constant? X coordinate is constant. This is a cos theta is fixed. So this is the line parallel to what? Y-axis. This is my y-axis. This is parallel to y-axis. Then the x coordinate is fixed. So the coordinates of P, x coordinate is a cos theta. So the only varying is y coordinate. Let us say either k or lambda. Then the coordinates of P may be taken as a cos theta comma k, which is on the ellipse. Am I correct or not? So x square by a square plus y square by b square equal to 1 has any point P is of the form a cos theta comma k. What is P? A cos theta comma k. Is it lies on the ellipse or not? X square by a square plus y square by b square is equal to 1. You just substitute the coordinates of P, replace x by a cos theta and y by k, you get the value of k. From that, you can easily write the coordinates of P. This is the way to find out the parametric equations of the ellipse. Now substitute the coordinates of P on ellipse. We obtain a square cos square theta by a square plus k square by b square is equals to 1. Implies k square by b square is nothing but 1 minus a square cos square theta by a square gets cancelled. 1 minus cos square theta, that is nothing but sin square theta. So k square is what? K square is plus or minus b sin theta. Therefore, P is equals to a cos theta comma b sin theta is any point on the ellipse. If you take P dash as a cos theta comma minus b sin theta, if P is in the first quadrant, P dash is in the fourth quadrant. So any point on the ellipse is taken as a cos theta comma b sin theta. So what is x coordinate? A cos theta. What is y coordinate? B sin theta. Hence we take x is equals to a cos theta, y is equals to b sin theta are the parametric equations of ellipse. This is the way to construct the parametric equations of ellipse through the definition of the eccentric angle of the point P. How to define eccentric angle? With the help of the auxiliary circle. Auxiliary circle, eccentric angle of the point and parametric equations. These three are depend one on other. Okay. Let us see the problem related to the parametric equations. Observe the problem. A line passing through origin O00 intersect two concentric circles of radii A and B at P comma Q. What is given to you? Some line is there. That line passing through origin and intersect two concentric circles of radii A and B at P and Q respectively. If the lines parallel to x-axis and y-axis through Q and P respectively meet at R, then the locus of R is what? That is the question. So how many circles are given to you? Two circles. What are their radii? A and B. A line through P, that is O origin, intersected two concentric circles at P and Q respectively. Understand? The lines parallel to x-axis and y-axis through Q and P respectively meet at R. We have to find out the locus of R. How to find this one? Let us see. Suppose the lines passing through origin makes an angle theta with the positive direction of x-axis. So I am going to write the line that is passing through origin that makes an angle theta with the positive direction of the x-axis. This is my x-axis, y-axis. This is the first circle having radius A. Okay, this is the first circle having radius A. This is the another circle which is concentric to the first circle having radius at P. Okay, these are two given circles. Am I correct or not? Now this is my line passing through origin, and that makes an angle theta with positive direction of x-axis. Now what is the duty of my line? My line intersects both the circles. This is the first circle, this is the second circle. First circle at this point and second circle at this point. Understand? So this is the first point of intersection Q, and this is the second point of intersection P as from the given data. Radius A, this is the circle of radius A, intersect at what? P. So this is my largest circle of radius A. It is intersected by y equal to x at P. This is the circle of radius B, intersects the line at Q. What is my line? Y is equals to some kx. That is the line passing through origin and makes an angle theta with the positive direction of x-axis. Now my question is, what is the distance from here to here? This is B. Now what is the distance from here to here? A. So my line makes an angle theta with positive direction of x-axis, and which is at a distance, which means here P. P is at a distance A from the origin. So can I take the coordinates of P are what? A cos theta comma A sin theta. Similarly, can you take the coordinates of Q as B cos theta comma B sin theta by using the definition of the parametric equations of straight line. By using the parametric equations of straight line. Am I correct or not? So this is the line parallel to x-axis meet the second circle. Now this is the line parallel to y-axis passing through P, that is the point of intersection of line and first circle. Where they meet each other? They meet at the point R. You have to find out the locus of R. That is your question. Am I correct or not? Already 90% of the problem is over. Once if you write the coordinates of P and Q, can you write the coordinates of R or not? This line is parallel to x-axis. This line is parallel to y-axis. Now let us see. What is Q? The coordinates of Q are B cos theta comma B sin theta, because the distance from here to here is B and angle is theta. By parametric equations, the coordinates of Q are B cos theta comma B sin theta. Now similarly, what are the coordinates of P? A cos theta comma B sin theta. These are the coordinates of P. This is A cos theta. This is ordinate. On ordinate, x coordinate is fixed. So what is the x coordinate of P? A cos theta. So the x coordinate of R is A cos theta. This is the line parallel to x-axis. So its ordinate is fixed. What is the ordinate of Q here? The ordinate of Q is B sin theta. This is B sin theta. So club this, what happened? The coordinates of R are A cos theta comma B sin theta. Therefore, we obtain the coordinates of R just by simple logic. R is equals to A cos theta comma B sin theta. This is my any point on the locus. This is my any point on the locus, because your line is varying. If theta is changed, the direction of the line is changed. Once if the direction of line is changed, their points of intersections are changed. Their corresponding point of intersection R is changed. So this R is varying. My R is varying. You are going to find the locus of R. So this is R, which is variable point. So let us be taken as H comma K say. Can you eliminate theta or not? You can easily eliminate this theta by H is equals to A cos theta, K is equal to B sin theta, implies cos theta is equals to H by A and sin theta is equals to K by V. By squaring and adding, we get H square by A square plus K square by B square is equals to 1. So can you write the locus of H comma K or not? Therefore, the locus of H comma K is an ellipse x square by A square plus y square by B square is equals to 1. This is my point R, which is variable point. You get some locus. That locus is an ellipse. X square by A square plus y square by B square is equal to 1. Let us see the locus. This is my locus. The locus is an ellipse. Once more. the locus of the required point of intersection is an ellipse. That is x square by a square plus y square by b square is equals to 1. So the entire problem is related to the parametric equations. Here we are using the parametric equations of straight line. Understand? So x is equals to the locus of h comma k is x square by a square plus y square by b square is equals to 1. On vertical line, x coordinate is fixed. On horizontal line, y coordinate is fixed. This is simple technique. So the coordinates of r are taken as by clubbing the x coordinate of q and y coordinate of p. Therefore, r is equals to a cos theta comma x coordinate of p and y coordinate of q, clubbing each other. So the coordinates of r are taken as a cos theta comma b sin theta. Understand? After getting the r, it is very easy to eliminate theta. So the locus of h comma k is an ellipse x square by a square plus y square by b square is equals to 1. Okay? Thank you.